Good afternoon, everyone, and welcome to this webinar in our science seminar series for the spring of 2022, brought to you by the Southeast Climate Adaptation Science Center. So my name is Carrie Furness, and I'm the program manager here at the Southeast CASC. I'm joined today by Brittany Salmons, our science communications intern, and who will be providing some support for this seminar. Thank you, Brittany. And so in this virtual seminar series, we're highlighting Southeast CASC funded projects that support resource management actions across the Southeast. And you'll see during this presentation how relevant this one is to that end. So yeah, let me start with letting you know what to expect from today's webinar. So we'll first go over some meeting logistics, request some feedback via a quick poll, and then we'll introduce our speaker for today. So Tina will present for about 45 minutes or so, and then we'll have lots of time for Q&A and discussion before we wrap up. So let me quickly cover some of the features of the Zoom interface, though many of us are, of course, pretty savvy in this. Though some of us do use other options. So you can see here that the controls on the bottom left, unmute, start your video, ask that you keep muted and your video off during the presentation just to reduce any distractions. Though during the Q&A, we will invite you to unmute and ask a question if you wish. So the chat window will be open the whole time. Please add in questions as they come up during the course of the presentation. And then we'll present those to the presenter at the end of her presentation. So we'll also be recording today's webinar, and you can access that recording on our website afterwards, and we'll give you that information at the end. So now we're going to launch a short poll just to get a bit of information about who's with us today and help us know how to get information out about these seminars. So if we'll just give you just about 30 seconds to fill that out. If you could provide that information for us, it'd be helpful. So we can sort of see both who's with us today, which might help our speakers sort of know how, I guess, anticipate questions perhaps, or know how to present some of the material. And so, yeah, it looks like we've got a nice mix of federal agencies, state agencies, and universities. So that's great. And thank you all for reading the newsletter and for passing the information around to each other. So that looks like a nice way that news of this webinar has gotten around. So, right, so we'll go ahead and end that now. And so thanks for sharing those, and go ahead and transition to our speaker. So Tina, you want to go ahead and start sharing, and while I introduce you. So are we having trouble with sharing, Tina? Is it coming up? There we go. Dr. Tina Mozelewski was a 2018-2019 Global Change Fellow with the Southeast CASC. So I'm starting her intro there because we've known Tina for a while and have been really impressed with her work and excited to have her present some of these results that are so relevant to research management decisions in the Southeast. So she's currently an ORISE postdoctoral fellow with the Northeast Climate Adaptation Science Center. So she has actually stayed in the CASC network, also kind of cool. Her work combines geospatial analytics, species distribution and occupancy modeling, and decision science to support habitat and species conservation in the face of global change. Tina's worked as a conservation researcher and practitioner in a diversity of ecosystems, from the deserts and riparian forests of the southwestern US to the temperate rainforests of the Pacific Northwest, to the pine and mixed hardwood forests of the Southeast, to the montane meadows and streams of California. So experience in a lot of places across North America. She received her PhD in fisheries, wildlife, and conservation biology from North Carolina State University, where her research used landscape change modeling to quantify the influence of climate change, land use change, and conservation action on landscape level connectivity and ecosystem state change in central North Carolina. So she'll be discussing some of that research, which was supported during her time as a Global Change Fellow. So the title of her presentation you can see today is Forecasting the Influence of Conservation Strategies on Landscape Connectivity. So I'll turn it over to you now, Tina. Thanks.
Thank you, Carrie. I am so excited to be here. I'm so excited to be talking with you all and just be back with the Southeast CASC. It's a really cool full circle moment. So thank you so much for having me. So a brief outline of the talk. I always try and start talks with management as a catalyst for the research that I do, and I really hope that that never changes. I'll talk a little bit about something called conservation forecasting, and then how that can be used for the evaluation of landscape connectivity. And we'll talk a little bit about conservation under global change, and then finally return back to management and talk about some of the implications of what I'm going to be talking about today for managers and decision makers. So it comes as no surprise that conservation demands are increasing faster than the resources available for conservation can keep up with. Global climate change is triggering changes in species phenology and shifting species distributions. It's disaggregating ecological communities, and it's also decoupling co-evolved relationships and altering habitat availability. And then land use change and land cover changes are driving habitat conversion, fragmenting intact habitat, and disrupting ecological service provision. And so these two stressors represent some of the most significant drivers of habitat loss worldwide, and they're expected to actually act synergistically, so exacerbating habitat decline and reducing landscape connectivity, which then increases the vulnerability of fragmented populations to extinction. And they're also resulting in novel ecosystems and altered disturbance regimes, and this changes the way that we can manage our landscapes. Not only are there more conservation demands than before, but the ways that we manage our landscapes, the way we conserve our landscapes aren't necessarily yielding the same results as they used to under global change. And so this is something that I saw firsthand. I used to work as a conservation practitioner in the desert Southwest. I was a habitat biologist there for the Arizona Game and Fish Department. And I coordinated on behalf of the Arizona Game and Fish Department with other agencies that were implementing riparian habitat restoration along the lower Colorado River. And so with an experienced staff of biologists and engineers dedicated to designing restoration projects and millions of dollars spent to implement them, the program was a regional leader in riparian restoration. So projects started, like you see on the left, and became these giant swaths of riparian forests along the lower Colorado River, and that really started facilitating and reinvigorating connectivity up this river system. And in the short term, the projects were super successful. Tree plantings grew rapidly. The focal species like the southwestern willow flycatcher started showing up shortly after site development. And really, by all metrics, these restoration projects were outperforming every expectation. But a drought raging in the desert Southwest began to derail restoration efforts. And projects had to be scaled back. Plantings started dying because there wasn't enough water to go around to cover the restoration that was already in place and restoration that was planned for future projects. And to me, this was mind-blowing, right? An all-star team of scientists and engineers that had more money and more resources and more resources at their disposal for conservation than most conservation projects will ever see, had failed to account for climate change and for drought in their restoration planning, and it cost them a lot of time and a lot of money. And this seemed like an especially critical lapse because we know that climate change is expected to further exacerbate drought in the desert Southwest in coming decades. And so this experience working as a practitioner was really formative for the type of research that I am doing and, hope to do in the future, because it revealed two very specific challenges that conservation needs to address to be more effective and efficient under global change. And so the first of those challenges is that our tried and true approaches to management may no longer be appropriate for the landscapes we want to manage. So how do we know when to abandon ship, when the ways that we have been managing aren't suitable anymore, and when we should try a different approach? And then the second challenge is, okay, well, if we're going to try a different approach, if we can't manage the way that we used to, then how should we manage? There's so much uncertainty in these systems around climate change and land use change, and then changing ecosystem dynamics. How do we know what new approaches are more likely to yield their intended conservation benefits, to reach their conservation targets, especially when there often aren't enough resources to go around to cover every conservation demand? How do we use our resources more wisely? So in other words, as landscapes are changing and conservation strategy outcomes are shifting and system-wide uncertainty is mounting, how can we hedge our bets when we think about conservation and management under global change? So one way we can do this, one approach, is to evaluate the consequences of conservation action, both the intended and unintended, through the use of something called conservation forecasting. And we can use powerful and really well-established modeling tools to forecast and evaluate the responses of both established and novel approaches to conservation and management before time and money are invested in on-the-ground implementation. There's been recent improvements in software and hardware, and then the rise of availability and accessibility of large ecological data sets. So we now have the capacity to project ecosystem changes in response both to environmental drivers like climate variability or different disturbance regimes, but also in response to human actions like land use change or management. And by allowing conservation actions to be tested over a range of possible futures. So a range of possible climate futures, a range of possible land use change scenarios. Conservation forecasting allows for the explicit incorporation of a lot of the key uncertainties that we face when we think about making management decisions on our landscapes. And conservation forecasting can also be really useful to validate whether a novel strategy, something that's untried, untested, is likely to achieve its target goals, how long it's going to take to achieve those goals, and then the relative cost to achieve them, all before strategy deployment on the ground. It can highlight when business as usual management may not be sufficient, and where more innovative or even more aggressive conservation approaches are required to achieve our conservation goals. And this information can be incredibly useful when we're deciding how to invest our limited conservation resources and plan for climate adaptive, future-focused conservation. Right, so one approach to conservation forecasting is through the use of a landscape change model. And landscape change models provide a means for understanding the interactions between geographical and climatic and socioeconomic drivers of land use and land cover changes, and then the dynamics of ecological systems. So it allows us to forecast changes in complex landscapes that cover, large spatial extents or long time horizons. And so landscape change models are especially useful because they can allow us to test multiple conservation strategies against multiple sources of landscape change, and then simultaneously compare trade-offs between strategies. So doing so can help us identify conservation approaches that work under multiple possible futures, and then again, maybe a better investment of our resources. And modeling has been increasingly used to identify spatial conservation priorities. But typically it's tested kind of the static implementation of one-time conservation actions, or it's lacked consideration of landscape dynamics when evaluating the outcomes of conservation. But we know that conservation is iterative. It doesn't just happen in one fell swoop. It's something that's happening gradually over time as, land is acquired and restored, or different conservation actions happen over time. And we also know that landscapes change all the time. And so conservation forecasting needs to evaluate the continuous and the dynamic implementation of multiple strategies and on dynamic landscapes to be able to replicate as closely as we can how conservation decisions are made, and the results of those decisions, which will then hopefully help us make smarter decisions. And so that's what this modeling framework that I'm going to be talking to you today about does. So I integrated the gradual and dynamic conservation actions into a landscape change model called Landis-2. And basically Landis-2 is this modeling framework that simulates ecological processes that affect forest habitat composition and vegetation structure. And it allows you to do that on large landscapes and out for, decades to centuries. And so Landis-2, this model, provides a way to link ecological processes and drivers of vegetation change, like disturbance dynamics and management, to capture spatially explicit landscape responses to conservation. How is the landscape and the habitat on the landscape responding to the ways that we manage it? And so this approach allowed me to test conservation strategy performance and then evaluate landscape level responses over time. And it also allowed me to incorporate what I mentioned earlier, a scenario framework, which is designed to capture system uncertainty from climate change, from land use change, from system stochasticity. So you're really getting a better idea of trends in conservation strategy performance on landscapes as they change. And so one thing I want to point out is Landis-2, depending on the questions that you want to ask, there's a lot of different extensions, a lot of different landscape processes and disturbance agents that you can incorporate into your model. For the model that I used, I incorporated hurricanes, land cover change. Then you also have things that characterize vegetation on the landscape, like soil and climate, disturbance, and then management actions and conservation actions, all to get projections of future forest habitat that then I used to evaluate conservation performance, these different conservation metrics. And so I applied this modeling framework to a landscape in central North Carolina. This is what I did for my dissertation research. I was at NC State, and so I picked a landscape close to home. So I used this model on a 1.5 million hectare landscape in central North Carolina, and it's bounded by South Carolina to the south, kind of Charlotte to the west, Greensboro, Winston-Salem to the north, and then the metropolitan area of Raleigh to the east. And I selected this study area for a few reasons. First, it's an incredibly active landscape for conservation. It's a highly diverse region because it contains portions of the Piedmont and the Sandhill and coastal plains ecoregions. And this study area has been kind of a hub for multi-agency conservation partnerships that have really been dedicated to both restoring longleaf pine forests and then enhancing connectivity between established natural resource areas like Uwharrie National Forest and Fort Bragg, largely for the benefit of threatened and endangered species like the red cockaded woodpecker. And then also this region is experiencing increasing urbanization pressures from and land use change as urban cores start to expand, Charlotte and Raleigh-Durham, as urbanization increases and people are moving to these areas It's fragmenting habitat, and it's making conservation simultaneously more urgent, but also increasingly more difficult. And then, climate change is also driving landscape change, which alters the feasibility and the timing of the management approaches that are so common in the study area, like prescribed burning, and potentially shifting forest type composition. So really, it's a fantastic place to ask questions about conservation and conservation performance as anthropogenic change accelerates. And an important one because so much time and energy and money is being invested in conservation here. So I used this modeling framework as basically a way to evaluate 4 different strategies for protected area network development. And so protected areas, I'm sure everyone is familiar. They're widely considered to be kind of a first line of defense in an effort to protect biodiversity because they reduce habitat loss, they provide central areas for species protection, and help to reduce species population declines. And so the strategies for protected area network development that I tested are things that as a manager myself, I saw being implemented on the landscape. And so when I talk about protected area network development, in modeling terms, what I'm really referring to is simulating the acquisition and restoration of land for different conservation purposes and through different restoration approaches over time. And so for this study, I basically simulated kind of this progressive acquisition and restoration where 1% of the landscape was acquired and restored every 5 years. And I did that amount of land acquisition and restoration because it equaled, I studied it from 2020 to 2100. And so it equaled out to about 17% of the landscape acquired and conserved, which was in line with the old conventional biological diversity terrestrial protected area conservation targets. So the strategies that I evaluated, the first one is what I called the cluster strategy. And so basically this strategy focused on clustering protected area development around already established conservation areas, with the goal kind of being creating larger core areas of protected habitat and reducing edge effects. And this strategy is thought to be maybe a more effective way to combat anthropogenic change than smaller scattered protected areas because it increases the effective size for populations, which may increase their resilience to change. And so for this strategy, the closer that an area on the landscape fell to an existing protected area, the higher the likelihood it was for acquisition and restoration for conservation purposes. Then I evaluated an economic strategy. So what happens if we acquire land as cheaply as possible for restoration purposes, which enables us to acquire more of it at any one time. So the economic strategy maximized kind of this concept of conservation return on investment by weighing economic costs with potential biodiversity benefits. So for this strategy, by acquiring lower cost parcels of land, I was able to conserve 25% more land and restore 25% more land at each time step, representing kind of an increased conservation return on investment. And I calculated the cost per acre of the study extent from parcel valuation data, with the parcels that were the lowest cost having the highest probability of selection for conservation. And I want to make a caveat here that for this study, we assumed economic stationarity when we considered parcel valuation. And then I also considered the geodiversity strategy, which preferentially selected areas on the landscape with the highest geodiversity characteristics, which encompassed kind of a natural range of variation in geological and geomorphological and soil characteristics, because high geodiversity on a landscape is assumed to mean greater numbers of environmental niches, which a lot of times results in higher levels of overall biodiversity. And so prioritizing geodiversity on landscapes for conservation may prove more resilient to climate change, because geodiversity kind of indicates a greater capacity to maintain species diversity and ecological function as the climate changes. For this strategy, areas that scored the highest in geodiversity, it was based on the Nature Conservancy's Resilient and Connected Landscapes data, and those had the highest probability of being selected for conservation and restoration. And then finally, I did an opportunistic strategy, which if anybody on the call has worked in conservation and habitat restoration, this was something I actually saw quite a bit, which is kind of this opportunistic acquisition of land. So either through conservation easement or if someone passed away and donated their property to a conservation entity. This opportunistic strategy is intended to represent kind of this random ad hoc conservation that occurs through these opportunistic conservation means. A brief note, anything under NLCD data that was high, medium, or low density residential, open water, or already designated as already conserved wasn't considered for acquisition and restoration in the study. And then for each of those different conservation strategies, each of those different approaches or drivers for land acquisition, I simulated 3 different restoration targets. So the first one being longleaf pine restoration, where all of the major hardwood species competitors were removed and longleaf pine was replanted. A pine mix restoration, where most hardwood species were removed, half of loblolly pine was removed, and then a pine mix was replanted. And then a hardwood mix restoration approach, which removed all loblolly pine, a kind of scattered mix of other tree cohort removal, and then replanted with white oak, which in North Carolina is a great food resource for a lot of the species for a lot of the species that conservation practitioners care about. Okay, so that I realize was an extensive setup, but now we'll get to the more exciting part of results. So kind of as a recap, I evaluated how each of the 4 conservation strategies improved habitat on the landscape. And I looked at how these changes in habitat configuration over time influenced landscape connectivity. And maintaining and enhancing landscape connectivity is incredibly important because it can reduce the impacts of habitat fragmentation, reducing species extinction risk. And it's been a major emphasis for land managers thinking about how to manage their landscapes for change globally, but especially in this study area. And this is super important because with so many conservation demands facing our managers, investing in conservation actions that can accommodate multiple needs and benefit multiple species is going to be really essential. And protected areas serve not as just these great hubs for conservation and core habitat, but they also can help to facilitate landscape connectivity over time. But depending on the approach that you decide to take for your protected area development, that can have differential impacts on landscape connectivity. Your strategy, some strategies might facilitate landscape connectivity for some species better than others. And so that's really kind of the key focus of this work. And so I won't belabor the modeling framework, but just wanted to show you that basically through the model, you get these projections of future forest habitat. And then I combined that with something called network theory to track changes in complex habitat networks over time for kind of this spatiotemporally dynamic assessment of landscape connectivity. And with network theory, it's basically a type of connectivity evaluation which represents these kind of discrete habitat patches on the landscape called nodes as being connected by these links. And links between habitat patches or nodes just characterize the ability of an organism to move between habitat patches. And I evaluated connectivity using a software called Conifor. And really wanted to establish kind of first a connectivity baseline. So before we start adding in global change drivers, how do each of these approaches to land acquisition and restoration drive connectivity on the landscape? I used a metric called the equivalent connected area, which basically measures the size of a single habitat patch that if you added it to the landscape and it was connected to everything else, would provide the same probability of connectivity as all of the existing habitat networks, which is honestly kind of a complicated metric to conceptualize, I think. But it's a really useful one because it gives you a metric of connectivity in either acres or hectares, like in some sort of actual area amount, which makes this metric easily comparable between different conservation strategies. And it kind of enables a direct comparison in total habitat area between our different approaches to conservation. So rather than taking a species-specific approach, I took a more general approach looking at 4 theoretical species guilds. So I looked at connectivity because, well, so we know that connectivity is incredibly influenced both by species habitat preferences and then also by how far a species is able to travel to try and reach different habitat patches. So I kind of wanted to get at that concept. So I looked at habitat specialists and generalist species at kind of a high and low dispersal distance. Specialist species were those that preferred mature longleaf pine forest. Generalist species were species that preferred mature, a more general pine mixed forest, and that excluded loblolly plantations. And then short dispersal distances were considered to be 1,000 meters, long distance dispersal 5,000 meters. Between habitat patches, a lot of times with graph theory, between habitat patches, the links are just kind of considered to be Euclidean distance. So how far is the distance between habitat patches as the crow flies? But I think what was incredibly useful and I think exciting about this modeling approach was that I was able to pull the habitat outputs from this Landis 2 modeling framework and use those not just to identify where habitat patches were, but also to characterize kind of the landscape matrix between habitat patches and take a least cost path approach to evaluating how much it actually costs to move between habitat patches for each of those 4 different species guild types. And resistance to movement, or like the cost to movement between habitat patches, was on a scale of 1 to 100, with each kind of cell on the landscape, 1 representing super easy to move through, 100 representing incredibly difficult to move through. And that rating scale was based on increasing in resistance cost the further away you get from this kind of ideal species forest habitat type. Okay, so what did I find? So the creation of protected area networks under any of the conservation strategies that I evaluated resulted in significant connectivity gains for both specialist species guilds, the high dispersal specialists, the low dispersal specialists, but it honestly didn't make a ton of change for our generalist species. The cluster strategy resulted in the greatest connectivity improvements for specialist species, regardless of their dispersal ability. And this is largely because for specialist species, their habitat is kind of relegated to the southeastern portion of the study extent where Fort Bragg is there, there's some Sandhills game lands there. And so the cluster strategy, by restoring land that was kind of connected already or adjacent to these established conservation areas, created a more feasible and kind of continuous spatial progression for specialist species out from their existing kind of habitat hubs. But for generalist species, habitat patch accessibility is kind of already pretty high across the landscape. And so we see not only less noticeable connectivity gains, but less noticeable differences between strategies. Yeah, we'll go with that. So what I want to get to is kind of how these results are visualized in maybe a more easy to digest way. So what you're seeing here are network graphs. And so basically they represent habitat patches. The bigger the circle you see, the larger the habitat patch, and then the link. And so over the duration of model simulations, habitat networks facilitated by each conservation strategy varied substantially for short and long distance dispersal specialist species. What you see in this figure is for long distance dispersal specialist species for the year 2100. This is a characterization of habitat networks under the cluster strategy and the economic strategy. And so the cluster strategy supported a lot fewer habitat nodes, but larger habitat nodes. And you see really centralized connections between these large habitat patches. Meanwhile, the economic strategy, there's quite a bit more habitat nodes, but a lot of times they're smaller, and there's quite a bit of habitat nodes that are actually unconnected from other habitat on the landscape. Meanwhile, this is for generalist species, again, cluster versus economic strategy, large, long dispersal distance species. And those habitat networks look a lot more similar because generalist species have access to more habitat patches on the landscape, and they experience a lot less resistance to movement. Yeah, their habitat network configurations look a lot more similar. So what does that mean for how we manage our landscapes? So kind of some conservation takeaways. So different conservation strategies resulted in differences in connectivity for specialist species. But for generalist species, the strategy that you pick matters less. So especially for generalist species, you could integrate additional priorities into the way that you prioritize land acquisition and restoration for conservation, because just focusing on improvements to connectivity for generalist species, you kind of get similar results across the board. And so this approach, kind of combining this landscape change modeling with this connectivity modeling, can really provide support for multi-criteria spatial prioritization for managers as they think about where they want to invest in conservation, in land acquisition, in restoration. And so that's great, but that was evaluating how these strategies performed on kind of a baseline landscape. So that didn't incorporate climate change, it didn't incorporate land use change, it just kind of looked at it looked at business as usual climate and land use change. So the real question is, can these approaches to conservation, these approaches to habitat acquisition or land acquisition and restoration for connectivity improvements, can it keep pace as climate and land use changes? So I looked at a suite of different global climate models under both RCP 4.5 and 8.5 to kind of bracket potential climate change futures in the study area. I also looked at 2 different land use change scenarios, one that represented kind of moderate population growth, one that represented really high population growth. You can see kind of these urban cores expanding in the images on the left. And then I looked at 2 conservation strategies for this evaluation, really the cluster strategy and the geodiversity strategy that have been suggested as more climate adaptive approaches to land acquisition. And so some results once climate change and land use change were considered. So connectivity actually always improved more under more extreme climate change scenarios, even compared to, RCP 4.5, even when land use change was taken into consideration, which frankly was surprising to me. And again, the cluster strategy performed best. But while land use change kind of reduced the effectiveness of conservation under both RCPs, this trend was a lot less noticeable under RCP 8.5, which again is really interesting because RCP 8.5 is expected, that was paired with the more extreme land use change scenario. Yeah, should have mentioned that. So I looked at both how connectivity changed under just climate change, RCP 4.5 and RCP 8.5, and then how it changed under a combined climate change, land use change scenario where RCP 4.5 was partnered with kind of the lower land use change scenario, and RCP 8.5 was partnered with the more aggressive land use change scenario. But thinking about this, the fact that connectivity improved more under RCP 8.5, it kind of supports these past studies that found that a changing climate is likely to have or potential to have positive impacts on longleaf pine and help it increase its dominance in the Southeast actually, because longleaf pine is more tolerant of drought and heat stress than some of the other tree species on the landscape. One thing I do want to point out, I think a really key management consideration here is that, even if a warmer climate favors the expansion of longleaf pine forests, which would increase habitat availability, which would increase connectivity, which is all great, it also could really challenge our capacity to do prescribed burning and actually maintain these longleaf pine forests in that habitat state and in a healthy habitat state over time, right? So with climate change, our burn windows could potentially change as land use change accelerates. When we're able to burn, where we're able to burn could get more complicated. And so that's one of the things that I don't think this model characterizes super well. So something to kind of keep in mind when we talk about management implications. So I found that the capacity of both conservation strategies to facilitate connectivity was reduced by land use change. And under RCP 4.5, that capacity was reduced about 25%. You can see kind of the smaller arrow on the left-hand side is conservation and both cluster and geodiversity strategies, along with a no conservation strategy as kind of a baseline. And just kind of the differences between connectivity outcomes from those strategies when land use change was incorporated compared to the difference between the conservation strategies and the no conservation, which is kind of the longer arrow on the top. Basically, land use change meant that the addition of conservation on the landscape to support connectivity was a little bit less effective. Under RCP 8.5, that message gets kind of a little mixed because longleaf pine was going gangbusters in the study area. And so you don't see as big of a distinction between kind of these no land use change and land use change scenarios, even though we know that land use change kind of under that framework was going to be more intense. So some conservation conclusions from this global change connectivity piece. So land use change is going to dampen the ability of conservation to actually keep pace with global change and improve connectivity substantially more than just kind of like a no conservation baseline. But climate change, when you're thinking about at least these longleaf pine forests, can kind of counteract some of those land use change effects, at least according to my model. And so I think this really emphasizes the importance of incorporating climate change and land use change into kind of these modeling frameworks when you're thinking about future focused conservation, and how those two effects either act synergistically or negate one another. I also want to point out that when land use change was included, the ability of conservation to actually increase connectivity above like kind of a no conservation baseline, that since that ability was reduced, this potentially highlights the need for the expansion of protected area networks, you know, beyond a 17% target. If you actually want to see significant connectivity improvements above kind of this no conservation baseline in the future. And again, this is, I think, a really important management consideration, because you could also look at these graphs and say, actually, you know, longleaf pine is going to be improving, connectivity is going to be improving. Maybe this isn't where we invest as many resources, as much money, as much time as we had originally planned. So it's just something to kind of keep in mind as you think about management in the future. So for the study area, I think some management takeaways from this work. If you're focused on kind of how I defined conservation for how I defined specialist species, right? These longleaf pine obligate species that want mature longleaf pine forests, clustering protected area network development around already established conservation cores, especially those in the southeastern portion of the study extent and kind of radiating out, seem to be the best way to facilitate connectivity. For generalist species, it's kind of a manager's choice, considering your other pressing objectives, your other goals. That's when you can really start bringing in kind of multi-criteria prioritization. And then as urbanization increases, more conservation, more aggressive conservation is going to be required if you really want to see significant connectivity gains above just kind of the baseline improvements that are happening as climate gets warmer and longleaf pine forests expand. And then for management implications at large, we know that there are trade-offs in conservation decisions. And so I think this framework presents a really exciting opportunity for scientists and managers to partner together and to evaluate the ways in which their management, the ways in which their conservation are going to kind of shape the trajectory of their landscapes in the future, and evaluate kind of through in silico testing how they can support in situ conservation and identify the strategies that are more likely to achieve management goals and objectives on changing landscapes. And then this framework also supports really regionally specific conservation. So it uses readily available data. It uses open source software. And so I think it presents a real opportunity where multiple drivers of change can be accommodated, and you can really take a regional or landscape specific focus on conservation. And then the last thing I want to say, which any modeler worth their salt will include, is the caveat that what I've presented today, talking about conservation forecasting, of course, is not a crystal ball. It is not going to tell you what strategy to use when and where and what the exact outcomes will be. But rather, I think it's a really useful tool for kind of hedging our bets and identifying strategies that either seem to be underperforming or really not working over time, or ones that are consistently performing well and that can help to perform the conservation decision-making process. And then I also want to acknowledge that doing this evaluation is not, it's not something that happens overnight. It was, granted, it was a learning curve. I was doing my dissertation, but it is incredibly time intensive. I think between the two different kind of results that I presented, there was over 20 million habitat patches and over 1 billion links between them that were evaluated. And so that took more than 35,000 hours on a high performance computing cluster at NC State, in addition to a really long time to parameterize the model. So this isn't something that I wish it was a little more accessible, but I do think it's a really, really useful tool. I want to say thank you to the funders, of course, the Southeast CASC, also the Sustainable Forestry Initiative, and also a grant that my advisor got from the Chancellor's Faculty Excellence Program from NC State, as well as several other grants and awards kind of along the way. And with that, I will say thank you for being a patient audience, and just open it up for questions.
Yeah, that's great, Tina. Thanks so much for that really awesome presentation. So I'll, if you want to ask a question, you can feel free to use that reactions bar at the bottom to raise your hand. And you can unmute yourself when you're called on to ask your question. You can also put it in the chat if you prefer. Let me just make sure I'm spotlighting Tina here in my view. Here we go. So yeah, I'll pause. I have some questions, but I'll open it to the group here and see if anyone has a question they want to pose.
I definitely saw hands. I don't know who wants to go first.
Yeah, I think that those were clapping hands, and I appreciate that. I appreciate that. It was a really great presentation. So this is a huge amount of work, obviously, and nicely summarized. So I'll jump in with a question. So you mentioned that your urban areas were excluded for restoration targets, which makes sense. Were they also excluded from your connectivity measurements? So could you make a connection through an urban area to between your nodes, I guess?
Yeah, absolutely. So that was part of the underlying landscape matrix when looking at kind of the links between habitat nodes, those urban cores, the different residential densities were incorporated in evaluating kind of the resistance distance between those two, between any two habitat patches. Yeah.
Okay, that's great. Yeah, and I see Karen, you want to unmute yourself and ask your question?
Hi, great talk, Tina. That was very interesting. I'm curious. So I worked prior to coming to Florida, I worked on the Colorado River and riparian restoration on the Colorado River, mostly in Mexico. And you know what I think was the primary limiting factor out there was mostly water availability. But I'm wondering if you think your tool could be applied to, you know, the examples that you provided at the beginning and how you see it might help with conservation efforts in that case.
Karen, that's a great question. And yes, this is actually one of my dream projects. So I would love to be able to make this even more complicated, I guess, by integrating not just this modeling framework that looks at habitat change over time, but also integrating different water use and water demand scenarios, and thinking about, especially for kind of these riparian forests, how not just climate change, not just land use change, but also actually water availability and water demand as more people are moving to the Southwest are influencing riparian forest habitat in the Southwest, and really the ability for those systems, when we think about connectivity, to serve as kind of their migratory corridors, both for seasonal migrants, but then also to facilitate climate change and climate adaptation, a species need to move. And so it's something that I would love to do. It is a dream project. I just need to find funding. But yes, great question.
Okay, well, I hope you do that, because I know here in Florida, we would also, we're thinking about wildlife corridor development and, prioritization of lands to acquire and benefits for water resources and water availability as well. So if you do end up doing that project, we would be very interested in looking at that as well.
I will keep you posted.
Okay, thank you.
So any funders for that, go ahead and put your name in the chat.
Right.
Right.
So are there other questions? I have one more, but maybe I'll defer and come back around to it so that we have time. Well, I want to open it to the to anyone else on the call. So maybe I'll ask it real quick. Oh, here it goes. So Erin, you want to go ahead and unmute yourself?
Martina, that was a great presentation, and I'll probably follow up with you more afterwards. But I was just curious what your feelings were on kind of the spatial extent, and maybe, with your experience in North Carolina, you could think about what would be a useful extent for the specific managers. If you think, 35,000 HPC hours, maybe they're looking more at species ranges. Just I'm thinking about regional, local, big picture analysis.
Yeah. So I think it could go one of two ways. So for my landscape, I was looking at 100 meter by 100 meter cell size, so fairly fine scale resolution. I think if you were interested in taking a more local approach, then you could really, and if you were interested in, more species or species that needed a finer scale, then obviously like scaling down of your landscape would help cut down on processing time. But I think kind of conversely, if you're looking at species range shifts, then I considered anything that was a single cell on the landscape to be a habitat patch, because I was looking at these species with really small dispersal distances. 1,000 meters isn't huge. So thinking about like that could be a small reptile or something. I didn't want to limit the analysis and exclude any habitat. So I think if you're looking for species range shifts, potentially as you're thinking about larger spatial extents, you're also thinking about habitat patch size and what actually you consider to be a node increasing. And so you could limit some of the really, really tiny guys, which would make your processing more efficient. But it's still a long freaking time. And so if I come up with any ways to like really streamline it, I'll let you know. But that's the best I've got right now.
All right, thanks.
Great, thanks. Yes, it looks like we're actually at the top of the hour. So I guess I'd say let's go ahead and give Tina another round of applause. That was really a great presentation, and appreciate you all joining in that discussion. So we have recorded this, and so could go back to review any points that you might have missed and be in touch with Tina. If you have follow-up questions, we'll ask her to put her email, best contact information in the chat at the end of this. So, and so, yes, we wanted to wrap up again with another thanks and to let you know about our next seminar, which we're going to be co-hosting with our partners at the South Atlantic and Southeast Conservation Blueprint team. And that's going to be held in conjunction with their regular third Thursday web forum. So it's going to be a presentation about a Southeast CASC supported project assessing the climate variability of wild turkeys across the southeastern U.S. So it's really interesting research about climate change of impacts on some of those species populations. So it's going to be given by Wes Boone here at North Carolina State University. So details for registration on that will be posted on our website in the next few weeks. And by registering for this webinar, you will be subscribed to our monthly newsletter list, where you'll be able to learn about some of these upcoming seminars and other events. You're, of course, always welcome to unsubscribe at any time. So we hope you won't. So at any rate, so I want to say thanks everybody for joining us today. And thanks again, Tina, for a really stellar presentation. So we'll close and I'll say, hope you all have a good rest of your day.